So welcome back. We are doing 7.5, ready, set, go, number 11. And what we're doing here is we're trying to like undo or unfold all of these to figure out what your answers are, right? And so you're going to use a lot of the theorems that we talked about and make sure that you understand how to apply those things. All right. So it first talks about if measure of angle LGH is 45 degrees. So the very first thing I do is make sure that I know what LGH are. And so this is angle LGH. You start at L, you trace your finger to G, and you trace your finger to H. That angle there, the yellow angle there, that's 45 degrees. So I'm going to draw in here and write 45 degrees. It's going to get a little squashed in there, but that's okay. And it says GHJ. GHJ is also 45 degrees. And one of your classmates mentioned, oh, Miss Johnson, those two angles are congruent. Exactly. Okay. So let's do a couple things here. If we know the inscribed angle, what else do we know? If we know the inscribed angle, what else do we know? Yes, the inscribed angle is half of the arc. So I'm just going to take this one by one. So ignore the second 45 that I wrote, right? And look at this piece of pizza. Everybody see my piece of pizza? So because it's an inscribed angle, the pizza crust is twice the angle, or the angle is twice the arc, or half the arc, sorry. The pizza crust is twice the angle, or the angle is half the arc. Okay? So that means that this guy here is 90 degrees. Does everybody see that? Very good. Okay. So I already got a bunch of people telling me, oh, Miss Johnson, I now understand. Okay. So because that's 90 degrees, what else do you know? Very good. I got some people like, man, people are trucking. Very good. Yes. Very good. Okay. So because I know that's true, then I know that that's 90 degrees. Now they gave me another angle. So then here, because this right here is also 45 degrees, what else do I know? That doesn't look like 45 degrees. Hold on. Can I make this bigger? No, not really. Okay, there. What else is 45 degrees? What else is 45 degrees? I mean, sorry. What else do you know now that you know that that's 45 degrees? Oh, someone's talking about triangles. Hold off on the triangle really quick. Hold off on the triangle. Go back to the. So if you know, whenever you have an inscribed angle, jump to the intercepted arc. So we are going to use the fact that you guys know that half of the intercepted arc equals inscribed angle. Okay. So I'll make my little list of theorems that I know. Yeah, it's also 90. Who is 90? Who is 90? Oh, wow. I didn't even see that. Good job. So very good. Arc GJ is also 90 degrees. Is everybody okay with that? Now, one of your classmates made mention to this angle down here. This angle here. Does everybody see this angle? Everybody trace LJH. LJH. Does everybody see that? So someone made mention like, oh, Miss Johnson, that's also 45 degrees. That's right. But why? Why is this in here also 45 degrees? Why is that angle in there also 45 degrees? Yeah, someone says, this is funny. Someone says, hey, Miss Johnson, it's that Z shape. Very good. Another way to describe it is that it has the same, give me a second. It has the same pizza crust. So look at this piece of pizza here. Does everybody see my piece of pizza there? It's a funny shaped pizza. Who cares? But it has the same pizza crust. Does everybody see my pizza crust? It's the same pizza crust. So that must mean that you can take half of 90 and it's 45, or those two angles are congruent. I don't care which way you understand it, but that's the same thing. I think the theorem you guys are talking about that we didn't technically prove in this class, but it exists, is if two inscribed angles, look at the yellow angle and the pink angle, if two angles intercept the same arc, if two inscribed angles intercept the same arc, then those two angles are congruent. Boom. Everybody okay with that? Now, some other people started mentioning other things because they started noticing other things. I'm going to erase my highlight so you guys can start looking at those things too. So I'll highlight things and then erase them just so that you guys can see them. No, that's okay. No worries. Someone else said, Miss Johnson, that triangle, we know that angle. So they were looking at triangle GMH. So everybody look at this triangle GMH. Green triangle GMH. Does everybody see that right triangle right there? I mean, that triangle right there? So you know that a triangle's sum adds up to 180. So I'm going to add that too. So triangle sum of angles is 180. Okay. So if you add all those up, this becomes 90 degrees. And it's faster for me to just go boom, boom. Is that okay? 90 degrees. What else do you see? Now, notice because you guys are running this, I haven't even looked at what questions they're asking me. I'm not even looking at those. I'm just saying, okay, now what do we know? Now what do we know? Okay, so that triangle can go away. Let me erase that triangle. Okay. What else do we know? I noticed there are triangles, 3 triangles on the top of M. Yeah. LKH is also 90. LKH. Ooh, is also 90. Good. Why is LKH also 90? That's right. This is also 90 right here. Why is this one 90? Why is that one 90? Look at his pizza crust. Here's the pizza. Here's the pizza crust. What do you notice about the piece of pizza and the pizza crust? It's the same. The only time the arc and the intercepted angle, wait, the intercepted arc and the inscribed, no, the intercepted arc and the angle are the same, is if that angle is a what kind of angle? So intercepted arc equals angle. What kind of angle is it? Yes, central angle. Central angle is an angle whose vertex is the center. So this is the center of the circle. Everybody okay with that? Is everybody okay with that? Yeah, it does make a quarter circle. Piece of pizza is in the pizza crust. Exactly. So this is legit how normal people cut pizza, right? They go to the center of the pizza as opposed to my slice of pink pizza or yellow pizza earlier, right? We don't go to the crust the other side. That would be mean because some of us, oh, I don't know, maybe it wouldn't be mean because some of us like more pizza crust than pizza. All right. So is everybody okay with that? We use that. Okay, let's see if we can answer any questions. Do you know what angle GMH is? GMH. Yep, we answered that. So this is 90 degrees. We did that. It says find arc LH. LH. Did you find arc LH? Yeah, it's 90 degrees. He's right here. He's the pizza crust we've been talking about. Yeah, this is 90 degrees. It says find angle LKH. LKH. Oh, we did that too. 90 degrees. Very good. Last angle, find JML. JML. Oh, we didn't find this one yet. We have to find JML. Someone says it's 90 as well. That looks like 90. There's several ways you can prove that that's 90. Why is this 90? Give me a reason why that could be 90. Look at that picture right there. Why is angle JML 90 degrees? Yeah, very good. Someone says vertical angles are congruent. Do you guys remember vertical angles? Vertical angles looks like an X to me, right? So it's this angle is congruent to this angle. Similarly, this angle is congruent to this angle. Everybody okay with that? Yeah, someone else said, hey, Ms. Johnson, the reason why I knew that is because I knew that this angle in here, GLJ, is also 45 degrees because he shares the same pizza crust, right, as angle GHJ, right? And then that's the sum of the angles is 45, 45, 90. Very good. So several different ways that you can figure that out. Vertical angles is probably one that you should be looking for because it's such a quick one. But if you saw that, I think you mentioned the Z way, that's absolutely fine. That's really good. You're just looking for ways to make it make sense. All right, so let's see. What else do we use? What else do you use? Can you find can I ask a question? I will ask this question. Ready? Is this 90 question mark? Is this 90 degrees? Is this 90 degrees? Yes or no? Good. No. So someone has this in their head that this is 90 because this angle right here is 90. Does everybody see that angle right there? Why is it not the same? Why can't it be 90? Because you can only have it if it's the central angle. Is that the center of the circle? The answer is no. That is not the center of the circle. Very good. So it's not 90, Miss Johnson? No. Here's another way for me to see why it's not 90. If that's 90, if I'll use if arc GJ is 90 and GH is 90 and HL is 90, doesn't that mean this would have to be 90? Dude, does JL look like it's congruent to GH? No. So no. So no, it's not 90 degrees. Let me undo a bunch of stuff. Hold on. So this is not 90 degrees here. That's wrong. Okay. So if you were to find it, you would probably need to look at angle K, like angle GKH. Okay, if you wanted to look through that. But for now, we're going to leave it right there because that's what they wanted us to do. I just wanted to make sure that no one thinks that that arc up there, GH, is 90 degrees. That's a no. Okay. It says triangle GKH has two sides that are radii of a circle. What? Did you draw that picture yet? I'm going to encourage you to draw a picture. So they have a circle, and it says GKH has two sides that are radii of a circle. So here, this is a horrible picture. But because these are radii of a circle, what kind of triangle is that? What kind of triangle is that? Not in particular. Sorry, let me make another one just in case. So these are, it's just two radii of a circle. So think about your bicycle wheel and pick any two spokes. What kind of triangle is that? So whenever I say what type of triangle, yeah. So you're thinking about equilateral, isosceles, scalene, right, acute, obtuse. So this is an isosceles triangle because these two sides are congruent. So this answer here is isosceles. There is one more type of triangle that could be formed. I'll leave that to you. All right. So I'm gonna pause right here. So before we pause, so these are the ones that we've been using. There are a couple more that we've been talking about in terms of tangents to a circle and tangents to a circle, as well as if you have an inscribed angle who intersects the endpoints of a diameter, right? But these are the main ones that we used over and over again. So if you're not comfortable with half the intercepted arc is the equal to the inscribed angle, or the sum of the measures of a triangle equals to 180, if you saw this picture as it was originally there, and it was just a mess, like it was so messy, there was like lines everywhere. What you want to start doing is you want to look for these things. Look for inscribed angles. Look for triangles. Look for central angles. Look for vertical angles. Because I'll guarantee you, if you start looking for them, they start like making themselves very obvious to you. Does that make sense? There's actually a theory about that. I think someone refers to it as like the red car theory. So, has this ever happened to you? Like you never paid attention to, I don't know. This happened to me when I bought a car recently. So I never noticed how many of the type of car that I just bought were on the road until I bought the car. And then all of a sudden, when I bought the car, I saw all those cars everywhere. Does that make sense? Yeah, there's literally a theory on that. I don't know what it's called, but it's basically because you weren't it was there before, but you weren't paying attention to it. But now that you have like that some people call it like skin in the game, now you're like, "Oh my gosh, everybody has this." So this will happen with a shirt, a phone, um a phone case, I don't know, whatever it is that you are particularly looking at, all of a sudden you will see it everywhere. So the next time you do that, like pay attention to a certain, I don't know, vehicle, type of phone, something, and then all of a sudden you'll see them everywhere. And it's not because they're everywhere and everyone's like copying you. It's more because, or it could be that, but it's also because when you start looking for something, it starts making itself obvious. So same thing goes here. If you look for intercepted arcs and inscribed angles, you're not going to see this as a mess. You're going to see it as, oh, that's an inscribed angle. There's a central angle. There's vertical angles. There's the intercepted arc. Oh, there's a bunch of triangles. Oh my gosh, Miss Johnson, there's a bunch of right triangles right there. Right? Okay. Yeah, same thing. Like say you just got a new dog, right? And you've never kind of paid attention to this type of dog, but all of a sudden you see this dog everywhere. Do you guys understand what I'm saying? Like I didn't know what a French bulldog was, and then once someone said like, "Oh, like a French bulldog." If you don't know what a French bulldog is, it's the ones that literally have their ears like this, and they kind of look like gremlins. To me, they do. And then so then after this person described what they were, I was like, "Oh." And then I saw them everywhere. And then for some reason, celebrities have this dog and they're really expensive dogs and they like I was like, "Oh my gosh, they're even on TV. I can't believe it." So that's what um I'm talking about when you first look at these problems. Okay? So just be patient with yourself.